equals x cubed here. So let's just take a moment to see what's going on with this nice little diagram. Here's y equals x cubed. Here are the x values. Now this is, on the y-axis, is the height function, right? Okay, so here's point A at 3, 27. So this is looking at the gradient on the curve y equals x cubed at A here when x equals 3. We know the height is 27. So 3 goes into the height function, out comes 27, right? Now I've picked a point B further up on the curve, can you see here? And what we've got here is an interactive way of seeing what happens to a number of things. So first of all, coordinate B. The x and y coordinates are here, okay? Now over here, this is the change in height, BC, 15.09 units. So TI-Nspire gives you a U for units. Here is the change in x, and here is the answer to the gradient, as in, you know, delta y over delta x, or rise over run. And as we drag this point closer and closer towards A, can you see that chord, that's the point connecting, the little line connecting A to B in pink, this is a good approximation for the exact gradient at A, but it's only an approximation. Look what happens as this B gets closer, the gradient is heading down towards, well, we're not too sure. Okay, so that's the idea, that we get a better approximation for the gradient at A as this point slides down here. Okay, so that's a concept that we're going to pick up in future lessons. We can also have a little look at what happens at the gradient at other points. If I say when x equals 2, can you see the height is A? Now the gradient at the moment is 22, but as I drag point B down towards, can you see the gradient's changing and it's getting closer and closer towards, well, we're not too sure, but maybe 12-ish, maybe. All right, so we can do that for each of the x coordinates here. And we can just drag down this so we can see clearly, can't we, that we're getting approximations for the gradient at point A as we slide this second point, point B, closer to point A. All right, so let's just go back here. Let's just take that up here. But actually the TI-Nspire does also allow us to work out the exact gradient. Okay, so what we're going to do here is going to do menu. We're going to do geometry. Actually, no, we're going to go back to analyze graph, because we can do it straight away. So dy by dx actually gives us the gradient at a point on the graph. So we are going to click a point on the graph. There it is. Boom. Okay. We're going to press escape. And now this point here and the number attached to it, this is the exact gradient on the graph at that point, right? So as I move over to here, as I move down to here, we've got the exact gradient. All right. So what I'm going to do now is I'm just going to delete this. I'm going to delete point A. I'm going to delete point B. I'm going to delete this name gradient. And can you see that obviously we understand that this represents the gradient. And now if I go menu, actions, coordinates and equations, I click on this, here are the coordinates of that point, right? So now let's press escape. Let's go double click on it one more time, click 3. Now look at this. So for this particular point here, when x equals 3, the height is 27, but also the gradient here is 27, which is quite interesting, isn't it? If I move it down here, if I go down to an x coordinate of 2, well, the height is 8, right, because 2 cubed is 8, but then the gradient here is 12. So this gives you a gradient field. We can also do this, menu, geometry. We can construct, and we can construct a, I wanted a tangent here, but I can't seem to choose it on here, so I think it's in a different menu. Let's just go see if I can geometry, points and lines. Can you see tangent? Oh, okay, there it is, 8 here. So tangent to this graph at this point, right? And then as I press escape, as I move that point round, you can kind of see the tangent here. And we're measuring the gradient of this tangent line. It's also giving us the equation of the tangent here, all right? I'm just looking at this number here, which is the gradient. So as I grab this, can you see the tangent line drawn? So let's change this now to 2. So the gradient is 12. And 1 here, the gradient is 3. So what I've got here already is, I think on this one. So when x equals 1, let's go back. The gradient is 3. When x equals 2, double click here, 2. The height is 8, but the gradient is 12. And when x equals 3, okay, so the height is 27 by this number, but the gradient is also 27, which is interesting. Let's just put one more value in there for 4. We might need to change the scale a little bit. Let's 4 here. Well, obviously 464, so let's just go change this into 70. Okay, so the height is 64, the gradient is 48. So the gradient is 48. Beautiful. Now what we're going to do is actually we're going to draw the gradient function for x cubed. So this picture here is the height function, y equals x cubed, and these are the numbers for the gradient function. So let's do doc, insert a data and spreadsheet. Let's have, this is the x input, and let's have the output here as gradient. Now what we'd like to know is there a particular function that will describe the gradients here? And you may have guessed it from the previous work we've done. We'll go menu, analyze, we'll do regression, and we will fit we can choose all these models, we're going to fit a quadratic. And there we have it. We actually have beautifully demonstrated that the gradient function, given we start with y equals x cubed, and we can change that to, if we want to, we can just change that to f of x equals x cubed here. We actually know that the gradient function is 3x squared, right? And so that's the introduction to the next lesson really, and how we move from height functions, y equals or f of x equals x cubed, into gradient functions, y equals 3x squared. And we're going to be looking at the links between those particular functions.